All right, let's talk about something pretty serious today. A security alert that, honestly, every single developer should know about. We're diving into a really sophisticated supply chain attack. That's when a piece of software you trust gets hijacked. And in this case, it turned a popular coding tool into a literal spy.
It's a scary thought, right? But it's a question we absolutely have to ask. Because for a little while, back in March 2024, if you were using a super common Python package called LiteLLM, the answer was a terrifying yes. So, let's get into how this actually happened.
So on that day, someone uploaded a malicious version of LiteLLM to the Python package index, PyPI. And look, this wasn't some accident or a simple bug. This was a weapon. An attacker intentionally poisoned the well, taking this really useful tool that people use to talk to different AI models and turning it into malware built for one thing: stealing your most sensitive secrets.
So, how on earth does something like this happen? How does what looks like a normal, everyday update become a full-blown security disaster? Let's break down exactly how this trusted tool got betrayed and how the whole thing was, thankfully, discovered.
Okay, this is where it gets really sneaky. The attackers completely bypass the normal safety checks. See, instead of going through the public GitHub repo where people can see the code, they pushed their malicious packages straight to PyPI. And they hid this nasty little file inside called LiteLLM_init.pth. Now, the whole point of a file like that is to run automatically whenever any Python process kicks off. That means the malware was live and running the second it was installed. The two versions you need to worry about are 1.82.7 and 1.82.8. And here's the wild part. The attackers messed up big time. That same trick that made the malware so powerful, running on every Python startup, it also applied to the malware's own processes. So it just started launching itself over and over and over in this crazy exponential spiral that just completely crashed the machine. It's called a fork bomb. And honestly, this incredibly loud, clumsy bug is what got them caught. The spy basically tripped over the furniture and set off every alarm in the house.
And this whole thing went down fast. I mean, really fast. The first bad version popped up just before 11 a.m. A couple of hours later, they find a second one. And then, get this. In a super bold move, the attackers tried to shut down the conversation about it by spamming the public GitHub issue with hundreds of bots to bury the warnings. It took almost 10 hours before the compromised versions were finally taken down. Just a chaotic day.
All right, so the malware is on a machine. What does it actually do? Well, it's not random. It follows a very clear, very destructive, three-step plan. First, it goes on a shopping spree. It collects every valuable secret it can possibly find. Then, it packages all that stolen data up, encrypts it, and exfiltrates it. Basically, it mails it home to a server the attackers control. And finally, it doesn't just pack up and leave. It tries to install a permanent backdoor, so it can get back in later and maybe even spread to other computers on the network. It's a classic smash, grab, and then linger.
And just look at this target list. This isn't random stuff. This is the absolute treasure trove for any hacker. We're talking SSH keys, which let you into servers, cloud credentials for AWS, Google Cloud, you name it, Kubernetes configs, database passwords, even crypto wallets. It specifically hunts for those .env files, which, as you know, is where developers often keep their secrets. This is a targeted list of the crown jewels of any modern tech company.
Now, to get all that stolen data out without being noticed, the attackers got clever. They encrypted everything and then sent it to this domain, models.littlellm.cloud. See how it's designed to look totally legitimate, like it's part of the real LiteLLM service? This helps all that malicious traffic just blend in with the normal stuff, making it way harder for any security tools to flag it as suspicious.
This quote from one of the reports just perfectly captures the sheer nerve of these attackers. They didn't just hack the package. When the community started to figure it out, they launched a counter-operation to actively sabotage the investigation. I mean, that shows a level of coordination and, frankly, audacity that is just, wow.
Okay, enough about the threat. That's the scary part. Now let's get to the solution. If you're thinking you might have been hit by this, here is a clear, four-step defense plan you can use to check your systems and start to recover. It's a pretty logical flow, right? First things first, find out if you even have the problem. Second, get that malicious code off your system and make sure to clear out any cached copies. Third, you've got to assume the malware tried to stick around, so you need to go hunting for any backdoors it might have left. And fourth, and this one is totally non-negotiable, you have to rotate all of your credentials.
And here are the exact commands you can use to do that.
You can run pip show LiteLLM just to check the version you have installed. You can use these find commands to look for that malicious.pth file or the backdoor tries to install. And if you're running Kubernetes, you need to check your pods for anything suspicious. These are real, concrete actions you can take right now to check your systems.
Look, I'm going to say this again because it is so important. This is the most critical step. Even after you've cleaned up the malware, you have to work from the assumption that the attackers already have your secrets. The data was sent out. So the only way to make what they stole worthless is to change everything. Every single SSH key, every cloud token, every API key. I know it's a huge pain, but it is absolutely essential to getting secure again after a breach like this.
And all of this really just brings us to the one big, fundamental question that this whole mess leaves us with. We all build our software on the work of others, right? I mean, that's the magic of open source. But this incident is just such a stark reminder that the trust we put in all these shared building blocks, it can be turned into a weapon. It forces us to stop and think, how do we really verify the code that runs, well, everything we build? It's a tough question, and it's one we're all going to be dealing with for a long, long time.